Hi, everyone. This is Greg Council with Periscript. Welcome to our second coffee and capture discussion. Coffee, hopefully you've got some coffee, even if it's in the afternoon for some of you, or in the evening. You could have an iced coffee. Iced coffee is what I'm having because it's pretty warm here already in the Denver area. So this, as we did before, we're going to take a topic, just a topic, and I'm going to discuss it for just a short amount of time, maybe 5 minutes, because I've got about 3 slides or something like that. We've got some questions that people have submitted, and I'll take those. And then you can certainly text in to the panelist, to the organizer, any other questions you might have along the way. Certainly you don't have to limit it to the topic that I'm discussing today. And I'm ready to answer any questions you have. So let's get going. So this topic is, gosh, you could say it's probably the most important aspect with regards to intelligent capture. And I don't know if you've read any of our blogs, but often we refer to capture as not CRM, or not something that you can test based on features and functionality, but that the core purpose of intelligent capture or intelligent document processing, however you know it, is about precision and being able to automate the most amount of tasks, document-oriented tasks. So those are classification tasks or separation tasks or data entry tasks, and do it in as accurate a manner as possible. So along the way, you're going to have to find out how well your system is performing. And so I'm going to cover a couple of aspects to that. Okay, so there are 2 things to consider. Actually, there are a lot of things to consider, but there are 2 major things that you need to consider when measuring a system. Now, measuring a system can be either in a proof of concept or a head-to-head evaluation of solutions, or just really managing your existing intelligent capture implementation. The first one is measuring. You need to measure things at the task level. Okay, what does that mean? Well, the task level means any type of action that a user might take for a document. So if that task is looking at a document and then typing in the name of the type of document, it could be like, oh, this is a benefits application, or this is an agreement, or this is a promissory note. It's the task of looking at that document and determining what it is and then typing the name of that document in. That's a task level. Another example of a task would be if you've got data entry tasks, you might need to look at the promissory note and find out when the date of that promissory note was. So a task would be entering in that date or the parties of that agreement. So I would, for each party, I would enter in that information, and each one of those is a discrete task. And you need to measure things at the task level. The reason being is that oftentimes organizations look at, wrongfully look at measurement at a page level or a document level. And things start to fall apart, because if you're looking at success criteria as to whether software, this intelligent capture software, can automate something at the page level, let's say it's an invoice and you've got 10 fields on that invoice. And if you're looking at success criteria, whether or not that invoice can be successfully automated 100%, you're going to find that very few invoices will be processed perfectly. Why is that? Because it's software and it's made by us imperfect humans, and even humans don't do it perfectly. There are always errors in that. So it's really important when you're looking at automating tasks and identifying the efficiencies of the system to understand how many of those tasks can be automated. That's the thing you want to do. The second piece of it is the accuracy of that task automation. So again, if I'm looking at classifying documents, and I just need to type in the name of each document. Overall, let's say I've got 100 different documents that I need to classify, and I type those in. How many of those tasks that I've been able to automate? So how many of those name assignments or class assignments of the system derived or was able to produce, how many of those are accurate? So if I've got 100 documents I need to classify, of those 100, how many of those answers were accurate? And that's the accuracy side of the equation. And those 2 bits of information are the 2 most important things you need to consider when looking at the precision or the performance of a system. And I'm going to go a little bit further and explain why that's the case. Okay, so let's look at measuring the tasks. Now, this is based off real world information. This is for receipts. So we measure everything. I mean, if it's one thing about this company, it's that there is just a heavy focus on precision, statistically measured precision. So let's look at the process of receipt data extraction. Let's say we've our tasks, what we want to do. We've got 5 fields on a receipt that we want to be able to extract. And let's look at it from 2 different measurements. One is at the receipt level. So how many of those receipts can be successful, have all the fields processed? And then we'll look at it from a field level or a task-based type of thing. So at the top of this table right here, you're going to see the measurements for 1 field, 2 fields, 3 fields, 4 fields, and 5 fields. And you're going to see the rough percentages of success for each one. And as you can see, the amount of success drops precipitously once you get past 2 fields. And why is that? It's that, generally, the more fields you have on a document or a page, the more chance you're going to have for error. And it's just like humans, systems are just the same, right? And systems don't perform, even though they can perform in some cases a lot better than humans, they still can have error. So the more fields we're looking at in terms of defining our success, let's take 3. So the likelihood of a receipt being able to be completely automated for 3 fields is, about 50%. The good thing is that's about 50% of your tasks that are automated at a receipt level. But if you're looking at 5 fields or 6 fields, then the amount of those receipts goes down, the percentage of those goes down. And there's a problem with that measurement because it's not really telling you how much labor or effort is actually removed. The right way to do it is looking at the task level or at the field level. So looking at it this way, if we're measuring it and our goal is to get 95% of all fields, of all data entry tasks automated, generally you're going to be able to, for a tuned system, achieve 80% plus. So I mean, in our systems, we achieve 87 and 90, 91, 92% of those fields can be successfully extracted. But again, we're not measuring it on a receipt level, we're measuring it on the task level. And again, as you reduce the stringency of those tasks and measurements, the amount of those things of the tasks automated can go up to 95% or 99%. An example would be for our check recognition products, where we're largely automating a few fields like the amount. So that's the legal and the numeric amount, and sometimes the date. We have accuracy levels and read rate levels, or the amount of data, at 98 or 99%. And what that means is 98 to 99% of the tasks at the data level are extracted, and 99% of those extracted data are accurate. So that's the way you want to do it. Now let's look at the other side of the measurement. Let's say we've got a solution, and the goal is obviously your objective is to always, you want to get 100% of the data out of these documents, right? I mean, who doesn't want 100%? Now, luckily, most of us are reasonable. So we start with 80, 85, hopefully. But ultimately, the objective, the Mars shot, if you will, is 100% of the data. If a quiz that I often like to pose is, if a vendor says I can get you 99% accuracy on your data, how much of that can you expect out? And a lot of people think, well, that's 99% of my data is 99% accurate, and that's wrong. Let me give you an example. In this little hexagon here, we've got 100% of the data you want, and I can give you a system that will give you about 10% of that data at 99% accuracy levels. What that means is I'm not getting a whole lot of automation, but yet the statement of 99% accurate data is absolutely correct. But I can pretty much guarantee you that nobody wants this. This is not automation in most people's minds, especially in the days of machine learning and things like that. So another way to look at it, and this is really more appropriate, is again, we're looking at the overall pool of data that you, or tasks that you want to automate. That is ultimately what you want, right? You want the majority of those tasks that are automated and the data that comes out of it to be very accurate, whether that's 95% accurate or 96 or 99 or whatnot. Again, the higher the accuracy level that you desire, chances are is the lower the amount of tasks that you actually can automate. But the key thing here that you want to consider is, just because somebody says 99% accuracy, that doesn't tell you a single thing. You've got to ask a lot more questions. How much of that data? So the upshot, if you approach a project with the wrong metrics, and unfortunately, a lot of organizations that we engage with haven't really thought it out in terms of the metrics. They're still focused on accuracy, and that's great. But if you're not fully understanding the number of tasks and the tasks that you want to get automated, and you've gone through the workflows, and you can come up with a good amount of tasks that are reasonable, that are an objective, that will save you money, and you're not looking at it from both how many of those tasks can be automated at a task level and the accuracy of that output, you are going to measure the system in the wrong way. And you have a higher probability of either just not meeting your objectives or having experience outright failure. And that is just the fact. We know a number of clients that have selected and use quote unquote OCR software where they are basically automating tasks and are manually verifying 100% of that data because the system in which they measured it wrong. It was never configured the right way, and they just don't know what data is good versus bad. And that's unfortunate because software these days, especially with the applications of machine learning where you can train and configure these systems like our smart learning capabilities, the capability is there and it's a lot easier to achieve than ever before. So that is the short little bit presentation. Hopefully everybody's still awake. I am going to switch over because I know that we had some questions already submitted. And I'll just pull some over. And if you already have some questions, please submit them. I don't know if we have an open mic or not, but let me just go ahead and run through some questions here. One here is, okay, this is a good question. So this question is around, it looks like the public sector where we're looking at, so it's municipalities or counties dealing with a very interesting and hot topic these days, which is voter registration and voting. So this question asked, how systems like ours can be applied to increase efficiency and reduce errors in recording documents such as real property records or voter registration and applications and changes. Okay, that's a really good question. So ultimately, and actually it kind of dovetails with what I just talked about, because ultimately what these systems are meant to do is take manual tasks associated with document-based information. So for example, if you've got a workflow process where you have people looking at real property records and recording this information in a system of record. So what they're doing is I don't know if they're having, if you have workflows where these documents are already sorted out to where you can pretty much guarantee that the documents that someone is working with are always the same. But a task could be just identifying what is the right record that you need to work with and what isn't, or supplementary information. But clearly, obviously, clearly there is also the data entry component of it. So the first order is to increase efficiency. Basically, what you're doing is, if out of all of that amount of data entry that you have associated with real property records or voter registration information, it doesn't matter what, you're removing a significant amount of that data entry activity. So if you've got a staff of 5 or 10 that are going through and they're basically working with these documents and performing data entry all day long, the objective of a intelligent capture system is to alleviate them from having to do that work and free them to do other types of work. So ultimately what you would see is 80 to 90% of that data entry activity goes away, leaving them to deal with the hard stuff, right? The stuff that the systems can't deal with. So that's, for both applications, it can be for changes, anything is really just removing that amount of those types of tasks from the daily work effort of staff. And if you have any follow-on questions, I don't know if you're on still, but if there are any follow-up questions, please feel free to type them in. There's another question, it was more ambiguous regarding wanting to explore ICR, or ICR being intelligent character recognition. So I don't know what you mean by exploring ICR, but it's a really, really hot topic these days because of deep learning neural networks that allow just a greater level of performance that we've ever had so far. So previously, if you've ever worked with intelligent character recognition, I do want to caution you because the traditional OCR vendors, like Abby and Nuance and things like that, while they offered support for both text as well as handwriting or handprint, the performance of the handprint was just never their focus, or the handwriting was just never the focus, and therefore the performance itself wasn't that good. And there was also a lot of requirements in terms of configuring a system to be able to optimize recognition of handwriting. For instance, you need to bring dictionaries. Dictionaries are word lists, or patterns like social security number patterns or date patterns, all in the effort to boost the performance. But with deep learning neural networks, we can focus solely on just the tremendous amount of data that we have to train a system and remove a lot of that configuration, so that you don't have to think as much about how you want to configure each type of handwritten field. And the benefit is you're not removing performance, because these systems can read the handwriting more and more like a human can. And so if I'm looking at something, if I'm looking at a document, I don't need to bring a word list or a dictionary or understand what a date format is, because I've kind of already learned it. And that's what deep learning neural networks allow us to do. And we've just released a new product called Field Expert AI. So we've got a number of products that use our new deep learning neural networks to provide both support for hand, print, handwriting, and cursive. We've got a number of different ways that you can get access to it. And Field Expert AI is a new discrete runtime API that allows you, that just significantly provides a great amount of performance. We've also got the same capabilities in our larger product called Form Extra AI. But ICR definitely is having a resurgence because of availability of new techniques and technologies and computing power to be able to save a significant amount of money in that kind of last 10 to 15 to 20% of exceptions, which typically is just extraordinary in terms of cost. So I don't know if we have any other questions, Rebecca, or has anybody else put anything out there?
We do have one more. We have a question that's come in. End users demand 99% accuracy released into workflow. Software can get us into the low to mid 90s, but the cost to get from there to 99% is exorbitant, especially when you consider SLAs. So this person's asking, what is the real achievability of STT in today's world?
Well, it really depends on the data. Okay. I mean, I hate to always say it depends, but it's really going to be dependent on the nature of the documents and the nature of the data. I can tell you matter of factly that a very structured, captured form, whether it's electronically captured or it's scanned but has a lot of quality control, can achieve 95% of the data at 98 to 99% accuracy, going straight through. If you're dealing with more unstructured information like agreements where there's no where you've got to do a lot more, bring a lot more to the table, such as natural language processing, I mean, it really depends there again. So, but we've got most of our use cases, especially when we're talking about a highly tuned system focused on removing the need to even manually review data. Most of our projects are in the 85% range, let's say upper 70s to mid 80s in terms of data that can flow straight through to downflow systems without any need for manual verification, that is statistically measured to be accurate at a given rate of 98 to 99% accuracy. So again, it's really about how you measure it, but the capabilities are there. I heard the word cost. Typically and historically, the ability to get to that type of level of precision took a significant amount of professional services. So it was not unlike, it would not be unlikely that an intelligent capture implementation project would entail about 3 to 4x on the professional services over the actual software cost. And that's simply in the ability to configure these systems manually, to test, tune, and iterate through those cycles over and over and over again, over greater amounts of data. And so it was a pretty expensive proposition that only a former boss of mine and colleague used to call only the fortunate 100 or the fortunate 500, and definitely not the unfortunate 5,000 or 10,000 of the organizations could afford. But with the advent of machine learning algorithms, I mean, we have a system called Smart Learning that can take tag sample data and automatically configure a system and optimize it basically at a push of a button. And we're expanding the number of use cases that it can handle. So it can handle things like invoices. It can handle things like EOBs. It can handle things definitely like structured forms for handwriting, for text, and we're moving into more complex things like more complex unstructured agreements. So hopefully that answered your question. Are there any other questions?
Nope, not at this time.
Okay, well, I want to thank everyone for joining, and we will see you again in a couple of weeks. Thanks a lot.
Thanks, Greg.